So some examples of the sine function. It says, how are the graphs y equals sine 2t and y equals sine 3t related? So first of all, our 2t inside there, that is going to cut the period in half. And then the second thing you see is the second graph has a 3 in front of it. And so that changes the amplitude. And so the first graph would have an amplitude of 1 because there'd be a 1 out in front of there. And the second graph would have an amplitude of 3. So here's how you graph these. You can draw the normal sine graph on the top of your page for reference, or keep flipping back and forth to that. So this kind of starts a little bit with section 5, I believe it is. So what we're going to do is take our center part here, the pi t, and set that equal to 0 and 2 pi. So either t equals 0 or t equals 2. So those are going to be our starting and ending points. And then we just need to find the middles. So the midpoint of this is 1. And then half of that is a half. And then half of that would be 3 halves. And so our amplitude is 1. And so you can mark wherever you decide you want 1 and -1 to be. And so you're going to make your normal sine curve. So you're going to start at the axis. Halfway you'll be up at the top. At the middle you'll be back down. At 3 halves you'll be to the bottom. And then 2 you'll be back to the middle. So again, this is one period of the sine graph. For our second one, the only thing that's different is we have this 4 out in front. So 4 is our amplitude. So we're going to go up to 4 on the y-axis and also down to 4. And then our x-axis points are going to stay the same because there is no b value this time. And then you can draw your normal sine graph. We start at 0, 0. Pi over 2 is up at 4. And then pi is down on the axis. 3 pi over 2 is down at -4, and 2 pi is back on the axis. And so again, this is one period of the sine graph.